do it. All right. All right. So we are working on math workshops now. I am going to check and see. Oh, I'm looking at the wrong thing. Okay. All right. So I am going to change seats. All right. Okay. So here's what I'm going to do. Hang on a minute. I am going to pause that. Maybe. So again, for science, today's learning objective is force and motion and energy. You know energy exists in many forms and can be observed in cycles, patterns, and systems. You will differentiate between conductors and insulators of thermal and electrical energy and be able to identify which material, metal, plastic, or styrofoam, is the best insulator. I will know you have learned this by reading your observations in the thermal energy lab sheet. Now, the thermal energy lab sheet. Like I said in my last class, we did this all on paper, and they ran out of time. And so I think what I want to do is stick with the digital version to kind of see if the digital version will work better. So, go into our homepage. I apologize, guys. Well, we need to do the warm-up first, don't we? Yes. Well, I can get to that. So go into the homepage. Warm-ups are in discussions. In class, people, I will give you your paper version of the warm-up. I will give that to you. Here you go. Number 1, once you open it, says circle all the objects below that are most likely less dense than water. Less dense than water. What does less dense mean for an object? It's going to do what in water? Less dense in water means it's going to do what, Rylan? Float. It's going to float. So, in class, traditional learners, you are doing it on paper. You're doing the warm-up on paper. Your warm-up is on paper, okay? Your warm-up is on paper. Your lab will be on the computer. Your warm-up is on paper. So number 1 says, circle all the objects below that are most likely less dense than water. You have a piece of tree bark, a ping pong ball, glass marble, penny, a blow-up ball, and nail, and a rock. So which one of those do you think will float? Because it'll be less dense than water. Number 2 says, is the statement below true or false? And explain your thinking. An astronaut's mass is less on the moon than on Earth. But an astronaut's weight is the same on both the moon and the Earth. So what you are doing is you're telling me, is this a true or false statement and why? Veronica, please get off that. Is it a true or false statement and why? All right, you have 5 minutes. And go. All right, who do we have? Okay, so yes, Chase. I'm sorry, what? Well, you state whether or not it's true or false and why. Why do you think it's true or false? All right. Raise your hand if you want to share what you have for number 1. What do we have for number 1? Saini. You think a penny will float? Yeah. You think a penny will float? You think a glass marble will float? No. Right. Do you think a penny would float? Here. You think so? Here, I got a penny. We're about to find out. Oh, let's see.
Pennies don't rust. Pennies can't rust. They turn to the color of Statue of Liberty. Oh, yeah. What?
All right, so here we go. Hang on a second. Let me move my camera. All right, you see this? That's a cup of water. I'm going to drop a penny in it. You think it's going to sink or float?
Sink.
It goes all the way to the bottom.
Dump it all out of the sink and watch it fall.
No, see, it's at the bottom.
A marble
It sinks.
A nail will sink. Oh.
Well, I know a nail sinks because I have one over here somewhere. What did I just do with it? Right here.
Why do you have a nail?
Hey, don't worry about why. Just for this. You see, a nail sinks too. Y'all ready? Uh-huh. You ready? It sinks too. It's a nail. It's a nail.
I can see you having a screw here and a nail.
I probably have a screw around here too. All right. So, raise your hand if you can tell us what sinks, what floats. Let's see if we can identify what floats. Chase. A blow-up ball. A what? Okay. Anything else? Tatum. A ping pong ball. What else? Rylan. And a piece of tree bark. All those 3 things are the only things on that list that float. Those float. A piece of tree bark, a blow-up ball, and a ping pong ball all float. The rest of them go bloop, 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 bloop. And they sink. They sink.
Some just go straight.
All right. Astronaut. An astronaut's mass is less on the moon than on the earth, but an astronaut's weight is the same on both the moon and the earth. True or false? True or false? Raise your hand. True or false? Rylan. Tatum. Well, it is false.
What?
It is false. No, you have the same mass.
Oh.
Your body stays the same. Everything about you stays the same. But think about the fact that here on Earth, we walk. We're grounded, aren't we? We don't float, do we? What happens when you go on the moon? You bounce off the Earth. You kind of float everywhere, don't you? So your weight changes, but not your mass. Your body stays the same. The amount of space you take up stays the same. But your weight changes. So it's false. Mass stays the same. Your weight changes. What? It is the gravity. You're absolutely correct. Right? All right. Fantastic warm-up. Go back to the home page. Go back to the home page. Scroll down to week 10. Those of you online are probably going to have to do a split screen, or you're going to have to toggle back and forth between the assignment work page and the lab, because I'm going to be doing a lab under the camera Today is week 10, day 1, Monday. What is thermal energy? What is thermal energy? Saini. It's heat energy. So what we are going to do today is we are going to say that we're having a party at the end of 4th grade. At the end of the year, we're having a party. The school's going to have a party. They have told us in 4th grade that said, you guys are in charge of the drinks. You're in charge of the drinks. You have to decide whether or not, what material are you going to store the ice in so it doesn't melt? What material do we store the ice in so it doesn't melt? What can we do to test the best material? What can we do? Rylan.
Get some ice and get the things you're going to use or you want to try.
Okay.
And you put them in there and see which one will melt faster than the other. Whenever one melts the slowest is probably the one you should use.
Okay, so the one that melts the slowest. Now, Rylan is completely on to something here because guess what we're going to do? We're going to test just that.
You got some ice?
I do have some ice. I'm going to have to go get it. So the first thing I want you to do is I want you to open up your assignment, week 10, day 1. Click on week 10, day 1. I want you to scroll down to the gray button that says load it, and I want you to load it. Load it. If it doesn't let you load it, you need to type in your email address and log into your Google email. If it does not let you load it, you need to log into your Google email because it won't let you load it unless you are in Google email. If you are having technical difficulties and cannot get into it, now is not the time to ask me because we will run out of time. Rylan.
Where is it at?
Week 10, day 1, module 10. Week 10, day 1. Your sheet should look like this. Now, I'm going to have one on paper. I am going to have one on paper. So, can y'all tell me what 3 materials we're going to be testing? Do you know? Nope. What 3 materials? Metal, plastic, and styrofoam. Rylan, how did you know that?
First of all, up there.
It is up there. Yes.
But it's not made out of metal.
Okay, well, here we go. I gotta make me a cup real quick. So, I have a metal cup, but it's really big and we're not gonna use it. So what I'm doing is I am makeshifting a metal cup, you know what I mean? It doesn't have to be fancy, it just has to hold ice, right? So I'm just kind of makeshifting a little metal cup. While I go get the ice, if you will notice, the first column wants you to make a prediction. Which one do you predict will be the best insulator? So, the best insulator is a number 1. The worst insulator is number 3. So what that means to be an insulator for ice means that it will not melt. So which one, metal, plastic, or styrofoam, is going to keep the metal from melting the most? Which one is going to keep the metal from melting the most? Okay? I am going to put this up there. So now you can see, and give me a second because I am going to go get, oh, this is going to be great. This is going to be perfect timing. I am going to go get the ice real quick, okay? So while y'all are making your predictions, I'm going to go get the ice. Give me a minute. You can write it or type it. Either way. One, two, or three. 1 is the best insulator, meaning the ice will not melt. 3 is the worst insulator, meaning the ice is going to completely melt. And then number 2 is the one in the middle, right?
No.
All right. So I got my ice. I'm not going to lie, my plan was to have you do the lab yourself, but it turned into a disaster in person. So now y'all get to watch me do it, and y'all get to observe. Jesselyn. I can't hear you. It's because I'm on mute. Hang on a minute. Now I can hear you. Talk to me. Oh, I said if the metal doesn't melt?
Yeah.
Oh, if the ice, we don't want the metal to melt. we don't want the metal to melt. We want the ice to either melt or not melt. So we want to protect the ice for the longest. So, do you guys have your predictions? Okay, I am not going to write down my predictions because I don't want you to steal mine, all right? I don't want you to, I will tell you this though, my predictions are wrong. In every lab I've done with this, it's wrong. Yes, Rylan?
You need a lid for all of them.
Yes, you're right, I do. So, but for the sake of our lab, just bear with me. All right, so I am going to drop a cube of ice in. And Rylan is correct. I need a lid. So I have my fancy lids here. They're index cards. I'm going to put my fancy lid on here. Well, you know, it does what it needs to. I am going to set a timer for 2 minutes. You know why 2 minutes? Because it says so on my lab sheet. Y'all are so right. So I'm going to set my timer for 2 minutes. We're going to hang out for 2 minutes and stare at each other awkwardly.
And then after that, you do 2 more minutes.
Well, first we're going to see what the results are. So we're going to wait 2 minutes. Sainey's got it. Thank you, Sainey. Then stop.
It just is.
Oh. I know what you mean. I know what you're saying. Hang on a second. I can fix that. Pipette. What are they called? Is that what it is? If you say so. Is it? I don't. Honestly, I've called them droppers. They've been droppers all my life. Here, rub a little bit of this on your nose. Wherever it's rubbing you raw. No, I know. Yeah. I know. But that ought to help. We got 30 seconds left. Did you get it? Thank you.
Okay, there. Oh, hang on.
Okay. Or throw it away. I don't care.
But then my nose gets all over this.
It will. You're right. And then you'll need some more. Can you not, like, pinch this part to keep it away from your nose? Oh.
If I pinch it, it'll just squeeze on my nose.
Right, which is supposed to keep it in place and not rub you. No, he doesn't have a bloody nose. All right. Let's see our water. So, I don't know. It worked in one of my classes where you were able to tell. So what I'm going to do is I'm going to use this little pipette, dropper. I call it a dropper. I think there's a technical term. I'm going to use this and I'm going to kind of squeeze out some of the water. So the styrofoam. Oh, the styrofoam hardly has any water. Can y'all see that? No?
Yeah, barely.
You can't really see it. I don't know how to get you guys to see that.
I can see it.
It's to tell you, though, there's like hardly any water in there. Let's see. Can you kind of see where the water's like right here? No. Can y'all just trust me that there's barely... Here, I can do this. Watch this. So, like, that's the amount of water. Y'all can't see that either. Anyway, there was hardly any water in my styrofoam cup. Jesselyn. No. Well, doing this experiment, though, you're supposed to be able to kind of, ideally, see. So this one has, my plastic has a little bit more water in it, okay? Like, the water out of my styrofoam cup is already dried on my card, by the way. So the water in my styrofoam cup is already dry. Like, it wasn't even enough to really for you to see it. I don't know if, let's see if we can zoom in on this. I don't know if you can kind of see the water level right there.
Oh, yeah, I see.
You can see the water level right there. There's a little bit of water in this one.
But as we talk, it still kind of melts.
It is. You're right. It is. It is. Let's see about the metal. I've got nothing in here. My metal's got nothing.
That's because it's the best insulator.
Well, that's your prediction. All right. My metal's got nothing in it. So I'm going to zoom back out. Okay. Well, it is aluminum. It's a soft metal.
What? It still does the same thing.
It does. All right. So now what I'm going to do is, okay, so now what you're going to do is, I think my number one would be metal, okay? So under the 2-minute results, I would put metal as number one because it didn't have any melted ice, right? Metal's my number one. My number two is going to be the styrofoam cup because it had a little bit of water. And my number three is going to be plastic. It had more water than the styrofoam. Okay? So after 2 minutes, these are our results. Okay? Styrofoam had a drop, and I might put that in there, like had a drop. Plastic had a few drops, and metal had nothing. I got nothing. Like there was no proof of melting. Yeah, all you need to do is put a number. I'm making little notes because it's the scientist in me, right? The scientist in me says, hey, put a few more details down, so I did. You only have to put numbers. So in column number 2, where it says 2-minute results, I want you to write 132. Type 132. Write or type 132. All right. We're going to do, and we're going to run out of time, so I'm going to do 2 minutes. For the next one. Ready?
While we're waiting, can we go ahead and wash our hands?
Yes, y'all go ahead. 2 minutes. Line up and wash. What is that? Oh, just throw it away. Throw it in the trash. Veronica, do you know how to type a text box in there? You do? Okay. Did you get 1, 2, and did you get the numbers in there? Okay, I just can't see that far. Yeah, yes. There should be a T. There should be a T somewhere on there that you can click on it and type it in.
Does this work? Still kind of covering my nose.
You'll just have to, yeah, the issue is that if somebody comes in here, you have to make sure it's over your nose. Okay.
Like I just do this real fast.
Yeah. Is it even up there? Does it rub you?
Yeah, right here it
What happens if you rub it up? If you have it high?
It almost touches my eyes.
Oh, that makes sense. Yeah. Okay. Yeah, it's just kind of.
And it's still like my nose is burning.
I bet it is. I'm gonna pull this out.
Let's turn back. Like it hurts. It's burning. Let's turn back.
I've got like 3 of them at home though. They don't work that well. It works good on this kind of carpet, but not regular carpet.
I do this.
Yeah, but I don't want you to have to stay that way all day.
Oh wait, I can find sweet spot. Got it.
Can you wait just a few seconds? Because we got to finish this lab real quick. We're going to finish this lab real quick. Like, I'm talking like 20 seconds. 10 seconds. Yeah. You're a big girl. We can handle it. You're mature enough, right? It will not take long, I promise. I don't know what you said. All right. Sit down. Level 0. All right. Let's check our styrofoam again. Let's check our styrofoam again. So styrofoam again. Ooh, there's a lot more water in the styrofoam. I think I used the wrong dropper though. That's okay. I don't think there was much in there. Let's check the plastic. Oh, the plastic's got a lot more. Oh yeah. Plastic has, I don't think y'all can see that, but my plastic line is up to here. Okay. My styrofoam line is here. Now let's check my metal line. I've got nothing. I got nothing in the metal. So which one's the number 1 now? Metal's number 1. Which one's number 2? Styrofoam. Which one's number 3? Plastic. All right. Guys online, we are going to go to lunch. Guys in class, go to lunch. Addison, you can go to the restroom first. And then we will type up the rest whenever we are done. You should have the table filled out based on your prediction, our 2-minute results, and then our 4-minute results. And so now you're going to go down here, and somebody asked me earlier, how do you add a text box? And when you look at this, there should be like a box over here that has a T. Maybe? Oh, this?
No.
Oh, here. Yeah. Okay. Oh, see, there it is. It says text box. It comes up. I don't know if you can see it with my bar in the way. There you go. So there's the T to add the text box. So you can click to add a text box. And remember, your observation. What observation were you looking for to determine the best materials to provide insulation for the ice? So what were we measuring? What were we measuring to determine which one would be the best insulator for our ice? You're not telling me you're typing it. Oh, okay, what's up? What was on the 4-minute results? Metal 1. Yeah. So make sure you're typing in complete sentences. I have some students that are like making a list. I don't want a list. I want complete sentences. Your conclusion, which material do you think will keep the ice cube colder for the longest amount of time? And then please describe your prediction in complete sentences. So based on, or I shouldn't, I guess, based on our test results, which one would you suggest we use to keep the ice colder, longer for our party? When you are done, please make sure you go up and click submit. Click the submit button so that I will get it and I will be able to read it and know that you know the difference between insulators and conductors and what they do for thermal energy. You have about 3 minutes left and we have to start, 3 minutes? No, you have 8 minutes left and then we have to start wrapping it up. When you are done, you can work on math workshops.
Miss Rich,
Yeah.
what does the observations question mean then?
What were we looking at when we were trying to decide which one was number 1, number 2, and number 3? What were we looking at? We measured the what? We observed the amount of we may have gotten it this time.